Another nice part that I really appreciate about this process is prior to this moment, before we knew about Laplace transforms and inverse Laplace, just think about how we would go about attacking this differential equation. We would create an auxiliary equation. We'd find complementary solutions. Then we would set up a particular solution. And then we'd have C1 and C2, so I'd have to take the first derivative so I could solve for C1 and evaluate. It would take us a while. So I hope you appreciate how much easier this process gets, especially when we're given initial conditions like this. All right, so what do I want to do? I want to do a Laplace transform from each of those terms. So the second derivative of y minus 3y prime plus 2y equals e to the negative 4t. So I'll do this term by term. Minus 3 Laplace plus 2 Laplace of y, and the Laplace of e to the negative 4t. Okay, so coming up to what the second derivative looks like, so that's this statement right here. That's going to be s squared minus s y of 0 minus y prime of 0. Okay, so let me write that what I just said there. So this one term right here, this guy right here, is going to become s squared, then y of s minus s y of 0 minus y prime of 0, and that's it. So we just replace that one term with that series of terms, and then the first derivative becomes, so highlight this, so this guy right here, minus 3, and then we're going to, that single derivative just becomes y s of y of s minus y of 0 plus 2 y of s, and then our Laplace transform for e to the negative 4t is just 1 over s plus 4. Now, this is the part that I love about Laplace transforms, because we can now take into account our initial conditions. So we have y of 1 right here. I can replace that with a 1. So y of 0 is 1. So I'll put a 1 there. And then the derivative, so that guy right there, I can replace that with a 5. So let's collect all that up. So I got an s squared y of s minus s minus 5 minus 3. And then we got our s y of s minus 1 minus 2y of s equals 1 plus s plus 1 over s plus 4. Okay, so let's collect up all of our y of s terms, because that's ultimately what we're trying to solve for, is y of s. So that's s squared y of s. I'll move the s, the minus 5. Let's see, we want minus. So I'm going to move the non-y of s terms over. So that's minus 3 s y of s minus 2 y of s. See, minus 5 plus 3, so it's giving me a 2, and if I bring it over, I get a positive 2 on the other side. And then that minus s becomes a plus s, so that's going to be s plus 2 plus 1 over s plus 4. And then let's factor out that y of s. So y of s, is s squared minus 3s minus 2 equals s plus 2 plus 1 over s plus 4. Okay, and let's do some fraction things. See if we can get those guys to play nice with each other. So, because ultimately I want to divide by s squared minus 3s minus 2. But you know what? That's actually factorable. So let's do this. Let's factor that. So that's s minus 2 and s minus 1. Oh, that's not right. Am I off a sign? Let me check my signs real quick. Oh dear. Okay, sorry guys. I just caught way up the beginning there. Hopefully I saved myself some emails. That it should be a plus 2y of s the whole time. So I done messed up. I'm just going to put a plus there. Which does allow it to be s minus 2, s minus 1. Okay. And then on this side, be nice if I could have s plus 2 combined with the s plus 4, so if I could have a common denominator there, and that'll make it a little bit easier to solve. So I'm going to do that. So I'm going to do s plus 2 times s plus 4 plus 1 all over s plus 4. I'm going to keep those factors on the left side for just a second. So that's s squared plus 2s, so plus 6s plus 8 plus 1, so plus 9 over s plus 4. Okay. And so now I can divide. So that's s squared plus 6s plus 9 over s minus 2, s minus 1, s plus 4. And hopefully you're like, wait a second, we have seen that before. And the answer is yes, yes we have. That is the partial fraction decomposition example we did earlier. So we can kind of speed up that conversion process, but understand that this is, if we hadn't done that, the amount of time it took us to do that partial fraction decomp, we would now be doing that part. So this would add a couple more minutes to our problem. But the point being is that I want to do an inverse transform then at this point. So my function is the inverse Laplace of this y of s thing, which, again, based on our earlier results, be negative 16/5 e to the t plus 25 over 6 e to the 2t plus 1 over 30 e to the negative 4t. And again, what's great about this process is because the initial conditions were built into our Laplace transform, we're done. Like, we don't have to do anything else. That is our initial, that is our function based on those initial conditions. Okay, so last little bit, kind of go through a chart here about what does this all mean. So now we have a different way that we can handle these differential equations. So if we can find a way to convert it into a Laplace transform, that's going to give us a way to do simple linear algebraic equation manipulations. And then once we've done that, then we can apply our inverse Laplace, and that should be the solution to our original initial value problem for that differential equation. So it's kind of a nice full circle process that we can use.